Okay, in lesson 9.2, we're going to continue to go on with our conversions. We did length. Well, length leads us to area, which is when you multiply two different lengths, and volume when you multiply three different lengths. So area would be like a square or a rectangle, and volume would be like a cube or a box. There are some more facts, and if you take a look at your textbook, it's really good at showing you some of these. I can draw in 2 dimensions, and then it really gets messy when I try to draw in 3 dimensions. But I am going to pause and try to do that on the board. Doesn't need to be in the video. Your chart. So a square foot is 144 square inches, 12 by 12. Square yard is 9 square feet, 3 times 3. Then it goes on to have acre in square feet or square yards, and a square mile is how many acres. I don't honestly know where the measurement acre came from. We also have some conversions between a square inch and square centimeters. So you don't have to remember all these, you just need to be able to use them. And I hope I have them all on that handout that I gave you. As you do your homework tonight, please let me know if you think I've left any of the facts off of your chart. All right, let's take a look at number 1. Use the table along with dimensional analysis to convert the given square unit to the square unit indicated. All right, an HA is a hectare. It is smaller than an acre. I don't know where it came from. It is a metric unit. All right, here we go. Here's my fact. I'm not going to write it down. I'm just going to circle it. I need to convert a hectare to an acre. So I circled the very last one in the chart so that I can think about it. I have 20.9 HAs over 1. What will the unit fraction look like? What has to go on bottom? The 0.4 HA, hectare, and 1 acre on top. Is that okay? Dimensional analysis revisited. The hectares cancel out. I have 20.9 on top. I have 0.4 on bottom. The only unit I have left is acre. And I will grab my calculator. And I have 20.9 divided by 0.4. And I get 52.25 acres. That doesn't make any sense. Oh, no, it does. I'm sorry. So are we okay? Anything new about this other than what the units are? I don't even really have to know what these units are like. I can still use dimensional analysis. I know that I needed those to cancel out and I needed acres to stay, and it did. Is that okay? All right. Let's take a look at one more. And would you do this one? You do this one, and then I'll know for sure you've got the dimensional analysis. You're going to convert 3 square inches into how many square centimeters? And the facts are right here, and it looks like it's the top fact. So if you will do that one, use your dimensional analysis. Okay, we'll go ahead and get back together. We're going to convert 3 square inches to however many square centimeters. So since I'm using dimensional analysis, I have to have my facts. I have 1 square inch is 6.5 square centimeters. Take 3 inches squared, put it over 1. How did you write your unit fraction? What went on bottom? Pardon? Yes, 1 inch squared. That means on top goes 6.5 centimeters squared. I know that I'm on the right track because the inches squareds cancel out. So with my calculator, I multiply 3 times 6.5 and I get 19.5. The only unit left is centimeters squared, and that is my answer. 3 square inches is 19.5 square centimeters. Are y'all feeling okay? It's just more dimensional analysis. All right, let's just take a quick look and talk about, we went to 2 dimensions where we talked about square units. Now we're going to look at cubic units. So if you looked at a cubic inch, it would be an inch by an inch by an inch, and it would form a little 3-dimensional cube. A centimeter, 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 and it's a cubic centimeter. By the way, they call it inch to the third, centimeter to the third, but in medicine, when they talk about a cubic centimeter, they call it a cc. I'm sure you've heard on TV or something, they'd say, give him 15 cc's of blah, blah, blah. They're talking about cubic centimeters. We'll talk more about that in a minute. All right. Capacity, we are used to talking about volumes. We're used to things like pints and quarts and ounces and gallons and cups and maybe even teaspoons and so on. But it is sometimes important to be able to talk about them in cubic units compared to capacity. Let me give you an example. Many years ago, probably 20 years ago, I had a house out in the country. I wanted a pool. I got an above ground pool. I needed to figure out how much water is it going to take to fill this pool up. Well, I knew how it measured in feet, and it was like a cylinder, and so I found out how many cubic feet it was. But water's not measured in cubic feet, is it? Water's measured in gallons. So it would have been really nice if I'd had this fact that 1 cubic foot is about 7.48 gallons. These are 2 different ways to measure the same thing. So sometimes we need to convert. Let's take a look. You're not going to see any real difference here because we're still using dimensional analysis. I know that this is kind of tiny. Let me see if I can make this bigger. All right, this is problem number 3. The problem number went off the screen. There we go. Use a table along with dimensional analysis to convert the given unit to the unit indicated. I have 25,000 cubic feet. How many gallons is that? All right, please look over at the chart because one of your jobs is going to be, can I find the fact? Where's the fact? Isn't it 1 cubic foot is about, because this is an approximate conversion, 7.48 gallons. So now let's do it. We've got our fact. We're going to take 25,000. Don't forget to write feet to the 3rd power. Put it over 1. Multiply it by the fact. What are you going to have on the bottom of the unit fraction? 1 foot to the third power, called a cubic foot. On top, you're going to have 7.48 gallons. Am I doing it right? Now, I always ask myself that question, and I see if the unit I want to get rid of is going away, and it is. So, with my calculator, I need to multiply 25,000 times 7.48. And I get a really large number. I get 187,000 gallons. But this is what I would have had to do to convert once I knew, based on feet, the capacity of my pool. I needed this fact to do the conversion so I'd know how many gallons of water would go in it. Does this make sense? Does it matter what you're converting? If you understand dimensional analysis, you can do any of them. Any questions? Okay. Number 4 is more of the same. So is 5, so is 6. Do y'all want to do another one of those, or can we go on to something that is a little bit different? Anybody want to do another dimensional analysis problem? Kind of tired of them? Okay. All right, all right, this is problem number 7. It says, and it seems like we're taking a big step aside, but we're not really. It says, in 1920, a certain country's population was 77,643,728. Big. And its area was 2,844,826 square miles. Okay, you could look that up in some almanac. Find the population density of that country to the nearest tenth, expressed in people per square kilometer. Okay, I have several things to do, and maybe it's going to require some dimensional analysis, maybe it's not. One thing that you need to know, this is just a fact, population density is the population divided by the area. You might want to write that down, but I'm going to show you how you don't have to remember it. It says, find the population density. Suppose you're taking a test. Find the population density, and all of a sudden you go, oh my gosh, I don't remember what goes on top and what goes on bottom in density. It's given to you. To the nearest tenth, express in, here it is, people per square kilometer. People, that's population. Square kilometer, that's area. It tells you which one to put on top and which one to put on bottom with the unit description. If I worked on this, and I took this population, 77 million plus, and I have this area, 2.8 million square miles, what's the problem? What's the issue? I got a little problem here. Thank you. The instructions said I have to give this density in people per square kilometer. And I was not given square kilometers. I was given square miles. So, part 1 of this problem, although it didn't tell me to do it this way, it didn't tell me at all. Part 1, change square miles to square kilometers. Does that make sense to everybody? And can you see that that could be easily overlooked in reading? All right, let's do it. Fact. They didn't give me a fact. But did I give you a handout with the facts? All right, let's look through. We're looking square miles to square kilometers. I found 1 mile squared, which is a different way to abbreviate square mile, is the same as, what did y'all find? 2.6? Everybody find that fact, because you need to be able to find the facts on your sheet. It's at the bottom of the first page in that bottom chart. What was I given? A big giant number that I can't remember. I was given 2,844,826 miles to the second power over 1. I multiply it by the unit fact. I'll put my 1 mile squared on bottom and the 2.6 kilometers squared on top. This problem did not say use dimensional analysis, but I realized I need it. So I have 2,844,826 times 2.6. All right, my miles squared canceled out, and I get 7,396,547.6 kilometers squared. Did anybody else do it on their calculator, and did you get the same number? It's over 1. I'm not writing the over 1. All right. Part 2. Now I have to find the population density. And I could go back. People per square kilometer. So I will put my people on top. Let's see, what was my people? It was 77,643,728 people compared to 7,396,547.6 kilometers squared. Your units are your friends. Write them down. Now these don't cancel out. It's people per square kilometer. Well, that's fine. That's what I'm supposed to have. So I will do the division with my numbers. 77,643,728 divided by 7,396,547.6. And I get, my page jumping around, I got 10.49729,309. This is people per kilometer squared. And my instructions said round to the nearest tenth. There's my tenths place, which is a 4. What does that 9 tell you to do? Round it up. So this is approximately 10.5 people per square kilometer. That's the density of the population. If you looked at a whole country and said, how squished in are these people? Something to consider. Think about Canada. There are dense pockets in Canada, but there's a lot of unused space in Canada because it's really, really cold up there. Think about China. There is no unused space there. the population density there is very high number. So that is one application of that. All right. Are we all right with that problem? It didn't say use dimensional analysis, but we saw that we didn't have the units we wanted. We had to go get a fact and turn it into the units we needed. All right, let's look at number 8 and see what we have to do. These are the problems that use the tools that we've become hopefully comfortable with. It says, a property that measures 10 hectares is for sale. How large is the property in acres? If the property is selling for $450,000, what is the price per acre? And if you pay attention to questions, you'll know what to put on top and what to put on bottom to do the final part of the problem. All right, let's look at the first one. Somebody help me out. How large is the property in acres? What are we going to do? Just describe it for me, please. It's gotten quiet in here. What units are we given? That weird one, hectares. What do we have to convert it to? Acres? All right, so I'm looking at my sheet and I am looking for acres and hectares, and I found it. Did y'all find it? Okay, part A. I have a fact, 1 acre equals 0.4 hectares, abbreviated HA. All right, I am given 10 HAs, put it over 1, multiply it by 1 acre on top, 0.4 hectares on bottom. I know I'm doing it right because those cancel out. I end up with 10 over 0.4 acres, and I divide that using my calculator. 10 divided by 0.4. 25 acres. Okay. Now, the sale is $450,000. We want to know what is the price per acre. So what goes on top? I'm finding a ratio, which means you're going to write a fraction. Price, per means over, acre. So I need price over acre. What's the price? $450,000. Number of acres, 25 acres. I'm going to divide 450,000 divided by 25, and I get 18,000. Now, something that's very important. What units is that? It's the same units that were in the problem. It's dollars over acres. It is $18,000 per acre. It fits with what the question asked. Money per acre. And I really don't, when it says what is the price per acre, it is letting you get away with just filling in the $18,000. That's the price per acre. And I wish that the whole unit was sitting there, because it ought to be. It's money per acre. So those were a couple of application problems, and let's take a look at 9. We don't have to do it, but we can talk about it. It says, a swimming pool has a volume of 43,635 cubic feet. Somebody measured it in feet and calculated its volume. Might have been length times width times height, might have been circular. They came up with the cubic feet. How many gallons of water does it hold? Can you see that you're going to convert from cubic feet to gallons? And can you find a fact to do that? It's not on the first sheet of your handout, it's on the second sheet up at the top. 1 cubic foot is about 7.48 gallons, so it's there. And I don't think we probably have, does anybody need to do that one? We've done one kind of like it, I think. All right, let me shrink this back down just a little. The problem concludes with working with capacity in the metric system, and then conversions between those in the US and the metric system. Oh, no, I'm sorry. This is all metric system. There is one thing that I want to really call your attention to, and it's this table up here. I believe I have it or something like it on your handout. I do have it. For some reason, when you need this, it does not pop up as part of a question. And so if you didn't have it in your notes, you might miss it. This is something kind of interesting. This was very thoughtful on the part of the metric system. All right, so I'm going to draw something up here. Suppose that this length is a centimeter. And this picture, as bad as it is a square centimeter. And this picture is a cubic centimeter. Centimeter by centimeter by centimeter. This is a centimeter cubed. This is something kind of interesting. If you poured water into it, that's supposed to be a drop, and you filled it up, a cubic centimeter holds 1 milliliter of fluid. So on television, when you hear somebody say, give him 20 cc's of glucose, a cc is a bad abbreviation, but it stands for cubic centimeter. He could have said, give him 20 milliliters. A milliliter is the liquid that goes into a cubic centimeter. We didn't do anything like that with our system. Ours is crazy, crazy. Ounces and inches don't have anything to do with each other. They do have something to do with each other in the metric system. So theirs was a well thought out system. Let's take a look. Let me see if I can find the problem that I needed that. Yeah, let's look at number 10. This may be our last problem. It says, a container of club soda has a volume of 8,200 cubic centimeters. And remember, that's centimeter to the third power. How many liters of soda does the container hold? I have 8,200 cubic centimeters. It wants me to decide how many liters that is. What am I going to do? What can I change? Look at your sheet. What can I change cubic centimeters to? Do you have a fact that changes cubic centimeters to liters? Look on the second page. Okay. And do we have that written down somewhere? You're right.
It's the
Second chart. Oh, okay. You know, when I did it, I didn't have this chart made. I didn't have it on here. And so I had to do some things on my own to figure that out, but you just did it. Table number 9.7 says that 1,000 cubic centimeters is 1 liter. And I use a cursive L, they use a capital L. But yay, thank you. You just got us what we needed. We need the fact, and I didn't even realize this fact was around on the sheet. 1,000 cubic centimeters is 1 liter. So we're going to take 8,200 cubic centimeters, put it over 1. What are we going to multiply it by? 1 liter over 1,000 cubic centimeters. Those cancel out, and we will get 8.2 liters. If you look at my printed notes, you'll see that I took an extra step. I converted the cubic centimeters into milliliters and then did a conversion. I made it a 2-step problem, but thanks to Sam, we got it in 1 step because he found the fact we needed. So are we okay? All right. If you had to, there is another problem, but I think you're going to be finding some densities and population densities and comparing them. If there were 2 concepts out of today's lesson from 9.1 and 9.2, what would be the 2 processes you learned? Dimensional analysis and the slide scale on the metric system. And that's it. We got a lot of different problems, but really only 2 concepts. We did do some stuff with density. Okay, so I'm going to go ahead and stop the video.